So far we have talked about moles and molar mass with just respect to elements, but now we're going to talk about what that means when it's a compound, which is two or more elements chemically combined. An element is defined as a substance that is made of just one type of atom, so copper, for example. All of the individual squares on the periodic table represent one individual element. A compound, then, is formed when two or more elements chemically combine. Chemical formulas, or how we write them with the symbols, are written as a combination of the symbols from the periodic table. So what do I mean with that? Na and Cl join together to form NaCl, which is table salt. Ca and O join together to form CaO. And you can read on through the list. Sometimes it's not always a one-to-one combination. As you can see down here, it's not always just one of each atom. Sometimes you can have more than one of a certain type of atom. And in this example, there are three types of atoms that combine to form that compound: sodium, carbon, and oxygen. When a chemical formula is written, sometimes there are these little numbers that you see written next to the element symbols. Well, all those mean are that that you do have more than one type of that atom in the compound. So for example, in this compound NaSO4, there are two sodium atoms that combine, so two of these guys, one sulfur, and four oxygens. So what happens is that it's really like you have two NAs, one S, and four oxygens, all bonded together to make this compound. So if you don't see a small number like the 2 or 4 here, as in there's no number right after the sulfur symbol, that means there's just one of that atom. Alright, so let's talk about molar mass of compounds. Before we go anywhere though, we should probably review what molar mass is in general. So recall that the mass of 1 mole in grams per mole of any element is numerically equal to its atomic mass in atomic mass units. So for example, carbon. The atomic mass of carbon is 12.01, as you can see here on the periodic table square. The molar mass of carbon then is 12.01 also. So then finding the molar mass of a compound is really similar. You just have to add the components together. So the mass of 1 mole of a compound is equal to the sum of the masses of 1 mole of every element in the compound. So what does that mean? For example, carbon monoxide. Well, this says dioxide. It should be monoxide. Carbon monoxide. CO. Well, the molar mass of carbon we know is 12.01, looking at the periodic table. And the molar mass of oxygen is 16. So what do? We add them together. And you get 28.01 grams per mole as the molar mass of carbon monoxide. 1 carbon and 1 oxygen, add them together to get the molar mass of the compound. So now I want you to take some time and practice solving for the molar mass of these compounds. Be careful here in number 5 though, there are 4 oxygens. So when you solve for this problem, solve for it by taking 1 calcium, 1 sulfur, and then adding together 4 oxygens to get the molar mass of the compound. Alright, so hopefully you got a chance to do these practice problems, and if not, I want you to go back now and actually work them out to make sure that you get these answers. So for sodium chloride, NaCl, the molar mass is 58.44. We talked about that in lab the other day. Calcium oxide, CaO, is 56.08. MgS, 56.38. ALN, 40.99. And then calcium sulfate, CaSO4, that is 136.15 grams per mole. I want you to put a star or something next to a problem that you struggled with in your notes so that we can talk about it when I come back. So now what? Well, we can do the mole problems that we've been doing, except now we're doing them for compounds instead of just elements. So now when you find the molar mass of something to be able to convert between grams and moles, you're going to just have to add some stuff together before you can use it in your conversion factors. So let's do an example. says how many grams are there in 3.28 moles of NaI? Well, your first step is to find the molar mass, which 1 sodium and 1 iodine is equal to 149.89 grams per mole. So 1 sodium is 22.99 grams per mole, and 1 iodine is 126.90 grams per mole. Add them together, you get 149.89. Step number 2 then is to use this as a conversion factor. So for every 1 mole of NaI, you have 149.89 grams of NaI. So setting up our problem, going from moles to grams, moles of NaI cancels out. You're left with an answer of 492 grams of NaI. Again, these cancel out. Make sure you put this example in your notes. Another example problem for your notes is how many moles are there in 4.98 grams of AgCl? Well, again, step number 1 is to figure out the molar mass of AgCl. So in 1 Ag, there is 107.87 grams per mole. And in 1 chlorine, we have 35.45 grams per mole. So we add them together. You get 143.32 grams per mole. So that's just in 1 mole of AgCl. So now we just take the problem, set it up the way that we have been. So 4.98 grams of AgCl times 1 mole divided by 143.32, which was the molar mass that we calculated. You get an answer. Grams of AgCl cancel out, and you're left with an answer in 0.0347 moles of AgCl. And the last thing I want to say is to not fret about doing problems that involve atoms of compounds or molecules or formula units. Just remember that those 3 things all mean the same thing. So atoms is the same thing as molecules, which is the same thing as formula units. So if you see that in a problem, don't freak out. Just do it the same way that you've been doing. You remember that Avogadro's number is your goal for this. Anytime you see the word atoms, molecules, or formula units, you use the conversion factor that 1 mole of anything is equal to 6.02 times 10 to the 23rd, whatever the unit may be. So don't freak out. I'm not going to do an example problem because you've done those already. So reference the video I sent off last class if you need to review how to do problems involving atoms.